Okay, so here's 35 from the worksheet. The difference with this one, and there's two things. One is it's a much higher power, or not much higher. It's the fourth power function, still a polynomial though, and you're also in a closed interval. So they're not doing the whole domain for all reals. They're just doing from -3 to +2. So, we could throw in the graphing calculator, take a look at it, which, pull it up real quick. Now, excuse me, I'm doing this back to back, so I'm gonna leave the derivative in here though, because it is kind of nice to have, but I'm gonna turn its graph off. I'm gonna now plug in here this guy. So 3x to the fourth plus 8x cubed minus 6x squared plus or minus 24x plus, oops, put the x in there, x plus 3. Again, I don't want to graph the derivative, so I'm going to leave that highlighted off there. So let's just graph this guy. Now I'm doing the general graph here because just to kind of get a look. Again, I only want between -3 and 2. So my window, I need from I'm going to do -4 to 3 just to get, a little to the left more than I need, a little more to the right. Now you can see here, my graph is not tall enough and it's not deep enough. So get back to the window. Let's go -20 and 25. To make it look prettier, you can change the Y scale. But that's roughly our graph. If you want to cut it off even more, actually, to really get an idea of what it looks like, if you do second quit, you can do second draw vertical, and that's -3. So vertical, -3. Okay, it's cutting that off there, which I still need to go up a little bit more, but I don't think the behavior is going to change anywhere in there. And then second quit, second draw, vertical at 2. And we can see, okay, yeah, we basically got, again, I could probably go up some, but it's probably just going to run into there. So there's the graph, and then I could trace, okay, I think it looks like there's a max around, -1, and there's an inflection point around x equals -1.5, and then there's a minimum around -2. So I could do all that stuff, but I'm just going to jump into the calculus because there's no point in wasting time just doing the graphing calculator right now. So to find the max and mins, again, we do our first derivative. So f prime of x is 12x cubed plus 24x squared minus 12x minus 24. Now, looking at this, oh no, this is a cubic. To factor it, to find the zeros, I'm going to take out the common factor of 12 first, and what's going to happen is it's going to work out more nicely than you think, because you get x cubed plus 2x squared minus x minus 2, which, if you remember your Algebra 2 and pre-calc, you can factor by grouping. So, x cubed plus 2x squared plus the quantity -x minus 2. You can take out an x squared here. That gets you x plus 2. You can take out a -1 here. That gets you x plus 2. And that factors to be x squared minus 1 times x plus 2, which then factors, and I'm going to bring it all together now. F prime of x is 12 times x plus 1 times x minus 1 times x plus 2. So even though it's ugly, because it's big, it does factor nicely. You're going to have 3 possible maxes or mins. Our values are at x equals -1, +1, -2. That's what we'll test for our first derivative. -2, -1, 1. Okay. Now, the second derivative then, come over here and take the derivative again. F double prime of x is, let's see here, 36x squared plus 48x minus 12. To try to make this a little easier to do, you can take out a 12. That gets you 3x squared plus 4x minus 1. And that actually factors 2, I think, to be, let's see here, 3x and x. No, wait, that doesn't factor. Nope, it's not going to factor. So we have to use the quadratic formula for that. So 3x squared plus 4x minus 1 equals 0. Opposite of b, negative 4, plus or minus the square root of 16 minus 3 times negative 1. So 16 minus 12, which is 28 again, all over 6. Just make sure I did that arithmetic real quick. 4 squared, which is 16, minus 4 times 3 times negative 1. And then if I do break that down, it's actually negative 4 plus or minus 2 root 7 over 6, which is negative 2 plus or minus root 7 over 3. So negative 2 thirds plus root 7 over 3, negative 2 thirds minus root 7 over 3. So, it's not pretty. Sorry, I've been doing this work here underneath the calculator. So it's not pretty, but it's going to work well enough, especially just for us to test points around. So, let's see here. Negative 2 thirds minus root 7 over 3, negative 2 thirds plus root 7 over 3. And we'll look at how that changes in the concavity in a moment. So, again, going back to doing this in the calculator, though, to save yourself the headache of doing all this work by hand, we can do y2, because that's the derivative. Remember, that's why I like to save it in that function there. y2 is the derivative. So I can do variables, function, y2 of something left than negative 2. So like negative 3. Which is negative 96. So it's negative 0. And then I just continue that, and it's going to look like this. What our slopes end up looking like. And then for the second derivative, what you could actually do if you wanted, this is actually, it's really a lot for the calculator to do. It really starts to freak out and slows down, but it does it. You can do math in deriv and do the derivative of y2 in there. So that's doing the derivative of the first derivative, which is the second derivative. Again, I don't want to look at the graph of that necessarily because it takes forever for the graph. I just want it stored in the calculator so I can do y3 of some values real easily. So, let's see. I need to know what those are as decimals first. So negative 2 thirds minus root 7 divided by 3, negative 1.5. And then if I want to know what it is, it's a positive. There's the plus in the middle. Pull it back up again, second enter. Push plus 0.21. So I can do y3, because that's where the second derivative is stored in the calculator. y3 of, like, I don't know, negative 2. Oh, need to put parentheses around it. And I get positive. And then I can do y3 of 0. Which is negative. And then I think this switches to positive because these are both zeros. Yeah. So now I know now I know, going back to my line test, this is the first derivative. This is the second derivative. This is negative slope to positive slope, so it's a min. This is positive slope to negative slope, so it's a max. This is negative to positive, so it's a min. This is concave up, concave down, and this is concave up as well. So I know those. I know all those things about the graphs. So now it's just a matter of kind of finding the y values for that. So I guess going back to this, I want to know in the graph. Oh, I'm sorry, one more thing I'm supposed to check as well, because I have endpoints in this, I'm bounded. I need to check negative 3 and 2. So I actually have 5 places to check for max and mins. Oh, and I can verify this. I know that this is a minimum because between a negative 2, right here, the graph is concave up, and negative 1, which is right here, it's got a negative concavity, so it's concave down, so that's why it's a max. And then 1 is after 0.21, where it's back at concave up again, that's why it's a minimum. So now, I don't know, we'll do f of negative 3, f of negative 2, f of negative 1, f of 1, and f of 2. Because again, f of negative 3 and f of positive 2 are our two boundaries. So I've already got that in y1, so I can just simply do variables y1. Actually, the easiest way to do this is let's go to our table. We've already got everything stored in y1. So y1, scroll up to, at negative 3, it's 48. Negative 2, it is 11. Negative 1, it is 16. 1, it is negative 16. And 2, it is 43. Okay, so, again, I know the endpoints, that's the highest value, so that's the absolute max of 48 at negative 3. Negative 2 is a minimum, and it's just a relative min, because negative 16 is below is below 11, so I know it's just relative min. 16 is negative 1 is a relative max. Negative 16 is again our lowest, it's a minimum, so it's absolute for our interval, absolute min, because remember it is closed. Again, we do have boundaries, so it's a closed interval. And then 43 is not the absolute max, that's 48, so it's just a relative max. So absolute max at negative 3 at 48, absolute min of negative 16 at 1, and then the rest are either relative mins or relative maxes. And then the last thing, it didn't ask us to find the inflection points, the x values of them, but if I wanted, or the y values, but if I wanted to know the value for the ordered pair of that, what I'd have to do is do y1 of that negative 2/3 plus root 7 over 3, which I can do actually, negative 2 divided by 3, see if we get a value for it. I don't think it's going to work out nicely, but it might, who knows. Never know until you try. So yeah, negative 2.35, whatever, so it's not a great one. So that would be like, negative 1.5 comma negative 2.36 or something like that. And then, I'm sorry, that was actually for this one here, so it's 0.21 comma that, negative 2.36. And then, second entry, change that to minus. And you get 13.32. So negative 1.5 comma 13.3. Or something like that. So those would be the inflection points.